So right now we're dealing with functions in our class, and we're looking at a function f of x equals 2x squared minus x minus 1. And the first question wants to know, is 2, 5 on the graph of f? Well, if 2, 5 was on the graph of f, that would mean that when x equals 2, this is a 2 is the x value of my point. Points are in the form xy, and my y value is 5. So if that's true, and another way of saying y equals 5 in this case, this is telling me when x is 2, f of 2 would equal my y value of 5. So just different ways of writing kind of the same thing. But technically what I want to do to see if that's a point on the graph is I want to go in here and I want to plug in for x, I want to plug in 2. And for f of x, I want to plug in, is that my y value? Is 5 equal to f of 2? So f of 2 is just replacing x in this equation with 2. And so going through with order of operations, let's simplify the right-hand side of the equation and see if we get a true statement or not. And so we have 2 times exponents first, so 2 times 2 is 4. Minus 2 minus 1 is 5 equal to 2 times 2 is 2 times 4, which is 8 minus 2 minus 1. Well, simplifying that down, 8 minus 2 is 6, and 6 minus 1 is 5. So we do get a true statement here that 5 equals 5. And so we can say that this point 2, 5 is on the graph of f. So for part B says, if x equals -2, what is f of x? What is the point on the graph of f? So if x is equal to -2, what we want to do is we want to go in here and we want to plug in now -2 wherever we see an x in this function. So f of -2 here is equal to 2. I tend to like to go through and put parentheses wherever I see the x and then go drop in the value that I'm evaluating this at, just to get used to that. In the future, we're going to be putting expressions in, and so hopefully that will stop you from having errors when you do that. So order of operations, exponents first before multiplication. So I'm going to bring down this 2, and I'm going to think about what is -2 times -2, which is 4. So I have 2 times 4. Recall, if you have a minus and negative, that's the same thing as adding. So this would be +2 minus 1. 2 times 4 is 8, +2 minus 1. So working from left to right, 8 plus 2 is 10, and 10 minus 1 is 9. So what this is really saying is when x is -2, my y value here is 9. So this is one solution to that equation, and that would be one of the points on that graph. We're now looking at part C. Part C, this was part B. Let me just write this down. This was part A. Part C says if f of x is equal to -1, what is x? And what are the point or points that are on the graph of f? So right now, this f of x value is representing our y. And so here we have x, f of x, or another way of saying again, xy. But this one has given me a particular value for what y is. It's giving me the value of -1 for y. And I'm trying to figure out what is the x value when y is -1. So again, another way to say y is f of x. So I'm going to go over here And I'm going to set my equation equal to -1. So I have -1 is equal to my equation 2x squared minus x minus 1. And so now I want to solve for the value of x for that equation. That would give me back an output of -1. So I see that I have a quadratic equation. And so to go about solving quadratic equations, usually we want to set it equal to 0. And so we can do that right here by adding 1 to both sides of our equation. So doing so, we have, well, -1 plus 1 is 0, is equal to 2x squared minus x. Well, this -1 plus 1 cancels, so it's plus 0. I don't need to write that. So now looking at it, since it's set equal to 0, first thing I would try is see if it's factorable. And I notice it is. Notice that both terms have x in common. So we can pull 1x out of both of those terms. So if I pull 1x out of 2x squared, what we're left with is 2x. And if I pull a single x out of -x, I would just be left with -1. So since I was able to factor it and the factors are set equal to 0, then I can set each factor equal to 0 and solve. Well, x equals 0, well, that's already solved, or 2x minus 1 is equal to 0. So solving for x here, I would add 1 on both sides. I get 2x equals 1. And then I would divide both sides by 2 to get rid of the multiplication between the 2 and the x, and I get x is equal to 1/2. So there's actually 2 separate x values that give me the same y value of -1. So the points on the graph when when y was -1, we found was when x was 0, we should get a y value of -1, and when x is 1/2, we should get a y value of -1. So these would be 2 additional points that are on the graph. And we just saw that -2,9 was a point, and we proved that 2,5 was a point for part A. Now we want to know what is the domain of f. So recall when we're finding the domain, we're looking at our function. In our case, this f of x equals 2x squared minus x minus 1. And when we're looking for the domain, we're thinking it's going to be all real numbers, except if there's any trouble spots in here, something that would give me back if I plugged in a value of x, it would give me back something that was imaginary, or if it wasn't defined. And so that would be things underneath the radicals. So I can't have the square root of -1 or a square root of a negative, because that doesn't give me back a real number. That gives me back the imaginary number I. So looking at this, I don't have any radicals in my equation, so I don't have to worry about any values of x giving me a negative underneath the radical. The other place that we have to be worried about right now are when we have values of x that give us 0 in the denominator. Well, I don't have any x in the denominator here. There's no x in the, I had something like x in the denominator here, 2 over x. X couldn't be 0 here. But I don't have any variable in the denominator for my equation. And so there's no trouble spots. And so any number I plug in for x would always give me back a real number. And so I can say that the domain is all real numbers. Or another way to state that, if we're talking about our interval notation, it's x going from -infinity to x going to +infinity is another way to state the domain there. So the next part, E, asks us to find the x-intercepts, if any, of the graph of f. So recall the x-intercepts occur when our y value is 0. Or another way to state that is when f of x is equal to 0. So our x-intercepts occur on the graph, any place where our y value is 0. So we want to go back to our equation up here, and we want to plug in 0 for f of x. So we get 0 equals 2x squared minus x minus 1. And we want to solve here for x. And so it's a quadratic equation. It's set equal to 0. So there's a couple different ways we can approach solving this. We could first see if it's factorable. Looking at it right away, I can't tell, but it wouldn't be too hard to see. Or we could use the quadratic formula. Those would be the two ways as I would approach this one if I wasn't told how to do it. I do notice that it's factorable. Unfortunately, that number in front of my x squared is not 1, so I have to look at what is my a value if I'm looking at ax squared plus bx plus c. To factor it, I have to look at what is my a value, which is 2. Multiply it by my c value, carry the sign, which is -1. So I'm looking for 2 times -1, which is -2. So there are two numbers that multiply to -2, but would add to give me my middle coefficient, in this case of -1, my b value. And so looking at what multiplies to -2 and which would add to -1, there are two numbers. -2 times +1 is -2, and -2 plus +1 gives me that -1. So the trick, if you're using that AC method, is rewrite the middle term, -x in this case, with the two numbers that we found. So we have 0 is equal to 2x squared. And then I'm going to rewrite -x as -2x minus x. So, oops, plus x. So if I sum those, that would get me back this up here. And then I'm going to do my -1. I'm just going to erase this to give myself room. So once we rewrite the middle term using the two numbers we found, the trick then was to do your factoring by grouping. And so 2x squared minus 2x, we can pull out a 2x from both of those terms. So if I pull a 2x squared out of x, if I pull a 2x out of 2x squared, I'm left with an x minus, and if I pull a 2x out of this 2x, I'm left with 1. Our goal is to have what's inside this parentheses the same as when we factor by grouping in the last two terms. And notice that's already the exact same thing. So if it helps you think of it that you're just pulling out a 1 here. So if I pull a 1 out of these last two terms, I'm just left with itself, x minus 1. So pulling out what they have in common, x minus 1. Well, if I pull out x minus 1, I'm left with this 2x. And if I pull out an x minus 1 here, I'm just left with this plus 1. Okay, so we factored this. We set our equation equal to 0. We factored it. It was factorable. If you didn't want to go through that process, you could have used the quadratic formula. And now we're setting each factor equal to 0 and solving. So we're looking at when is x minus 1 equal to 0? Well, if I added 1 to both sides, I get x is 1. And I'm looking at when is the other factor 2x plus 1 equal to 0. So a little more work there. If I subtract 1 on both sides, isolating my x, I get 2x equals -1. And if I divide both sides by 2, I get x is -1/2. So there's two x values, which give me a y value of 0. So there's two x-intercepts. We have one at 1, 0. So that's 1 point on the graph. And we have one at -1/2, 0. Okay, so now I'm just looking at the last part of that question. Part F, it says list the y-intercepts, if there is one, of the graph. The y-intercept actually is a lot easier to do when you have the equation. So we want to look at here, this part F, the y-intercept. Well, the y-intercept occurs when x is 0. So all we have to do here is go back to our equation, which I'm going to list here because I've made it so small. F of x equals 2x squared minus x minus 1. And again, y-intercept occurs when x is equal to 0. And so all we have to do here is we need to figure out what y is when x is equal to 0. And so we can denote that by f of 0. And go in here, wherever we see an x, we're replacing it with 0. And so doing so, we get 2 times 0 squared. Well, 0 squared is 0, times 2 is 0, minus 0 is 0. So all we're left with is -1. And so our y-intercept is when y is -1. And so I could write that as a point as 0, -1.